You cannot pour water into a sponge that is already full. The exact same principle governs glycogen replenishment, the biological process of restoring depleted carbohydrate reserves in your muscles and liver. It dictates your absolute metabolic outcome. Replenishing an empty vault drives peak performance, while replenishing a full vault triggers fat storage, which is what we've explored in our last few segments. When it comes to the body, carbohydrate tolerance is not a genetic lottery. Holistically, it is a strict mathematical equation based entirely on an individual's current glycogen capacity. Observations state that glycogen is the storage form of glucose converted from food carbohydrates. Healthy, active persons remove blood glucose rapidly when glucose is in excess. So, how can an individual improve glycogen capacity to gain from the nutritional benefits of carbohydrates? A few ways to estimate glycogen capacity are: 1. When in deficit, an energy crash during intense exercise may signal depleted muscle glycogen, and 2. When in excess, rapid weight gain after carbohydrate loading. 1 to 2 pounds in 1 to 2 days means your glycogen stores may be full or already saturated. Glycogen is stored in the body along with water, about 3 grams of water for every 1 gram of glycogen, which can increase body weight and impact exercise performance. These subtle cues can help taper a more optimized intake of carbohydrates, so a combination of observing performance or body weight. Additionally, the body maintains 2 primary glucose storage depots. The first is your liver. It holds roughly 100 grams of glycogen. This is your brain's baseline fuel reserve. It fills quickly, and it spills over easily. Because the brain is an obligate user of blood glucose, it is essential to maintain normal blood glucose concentrations for individuals who train intensely during rest and exercise. But don't forget quality matters. When this vault is full, the liver shuts the door, insulin spikes, and excess glucose is aggressively forced into fat cells via de novo lipogenesis, which is fat creation from excess glucose, carbohydrates. The second vault is your skeletal muscle. Depending on your lean mass, this vault holds between 400 and 500 grams of glycogen. This is your massive primary metabolic sponge. But here is the physiological reality: muscle glycogen is highly localized. For example, doing a set of bicep curls does not empty the glycogen vaults in your legs. To create a massive carbohydrate buffer and prevent spillover, you must systematically wring out the sponge through sustained high-intensity mechanical tension. You must actively create a biological deficit before you introduce the fuel. Under healthy physiological conditions, some of these mechanisms are self-fulfilling. When your glycogen vaults are saturated, the brain can signal satiety, naturally curbing the urge to consume excess carbohydrates. A second approach is methodical fasting, to establish a precise biological deficit. And third, you can force depletion through mechanical output, using either sustained endurance exercise or high-intensity activity to actively drain the metabolic sponge. If you consume carbohydrates while your metabolic sponge is already full, it can trigger the passive fat trap. But if you consume them when the sponge is empty, it can fuel peak performance and cellular recovery without expanding adipose tissue. The math dictates the physiological outcome, so it's not just measuring the amount of carbs, but starting from the fundamentals, your personal baseline, by considering physiological factors like deficit, excess, or proportion to training. In Part 12, we'll explore some of the protocols required to strategically empty these vaults. Go deeper with high-performance health. Subscribe to join this resource.